Alright, let me confess right off the bat, this problem is not easy. Alright, there's lots of steps involved in this problem here. But follow along or pause the video if you need to along the way. Alright, I'm going to use integration by substitution, and as I showed in a previous video or a different video, you should remember and recall that the derivative of the natural log of x is equal to 1 over x. Alright, and we're assuming that x is a positive number. It's a non-negative number. Okay, so what we have then is we're going to, right, in this problem here, let's let u equal our entire denominator of x plus 1. Okay, before I take the derivative of this, because substitution says once we define what u is equal to, then we take the derivative of u with respect to x. But before I do that, let me show you one more thing. So we're going to let u equal, right, just kind of box this off here, x plus 1. What is x? Let's see if we can, in this simple equation, get x all by itself. Do you see that if I wanted x by itself, I would subtract 1 from both sides? So if I wanted to, I could write it this way as well. I could say, hey, x is equal to u minus 1. Right, that's a 1 there. So keep these two things in mind. We're going to need them in just a second here, okay? Alright, so let's go back to our original substitution here. That was u is equal to x plus 1. Let's go find out what du, the derivative of u with respect to x, is. Well, the derivative of this first box is simply just a 1, right? Because the derivative of a constant is gone, it's just 0. And the derivative of x, well, its coefficient is a 1, so we're just left with 1. That's it. If I wanted du all by itself, I would multiply both sides by dx, right? Multiply both sides by dx. These guys are out of here. So I've got du is equal to simply dx. Alright, so I've got three things now. I've got three equations that I can use to substitute here. Right? We're going to do a little algebra on the side as well. But first, let me rewrite this. So here's my original problem. I'm going to rewrite it this way now. I'm going to go from 0 to 7. And in place of x plus 1, in place of that denominator, I'm going to put in, right, in place of x plus 1, I'm going to put in a u. So my denominator is a u. In place of dx, right, in place of dx, I can put in du. Right, so that turned into that. That turned into that. And my numerator, 2x minus 3, instead of writing it this way, because look, that would just, if I wrote it as 2x minus 3, I'd be left with a numerator that's in terms of x, and I don't want that. I want everything in terms of u. So what I'm going to do is I'm going to replace, right, I'm going to replace this x with u minus 1. That's why I wrote it this way just a moment ago here. Right? Instead of x, I can write this as u minus 1, and I'm going to put that in parentheses, u minus 1 minus that 3. So now look, I've got a new problem. It's really the same problem, but written slightly different, using all of this substitution stuff over here. Okay. Now let me work out the numerator a little bit here. I'm going to do that on a separate paper. Let's do that over here, maybe on the side. Right. Let's do a little bit of algebra. Here's what my numerator looks like. Right, and this is all over this denominator of u. If I was to work this out a little bit here, let's do some algebra. I could distribute the 2, which makes it 2u minus 2 minus 3 all over u. Hey, add these two like terms over here. You've got 2u minus 5 all over u. But I'm going to separate this out. I'm going to separate them out into two separate terms, right, with u as my common denominator. So I could write it this way, 2u over u minus 5 over u. Right, so u is acting as my common denominator. And you see in this first term here, the u's cancel out. So I really have 2 minus 5 over u. Alright, so if I wanted then, I could go back to my original problem and write this as the integral from 0 to 7 of 2 minus 5 over u du. I hope that makes a little bit more sense to you now. Now why would I do that? Well, here's why, okay? I've got, let's see, I've got the antiderivative, or the integral of 2 with respect to u is simply 2u. And the antiderivative of this, remember, right, This is what I showed you earlier. Recall that the derivative of natural log is 1 over x. So the antiderivative of this, right, the antiderivative of that goes back to natural log. Okay, so the antiderivative of negative 5 over u goes back to negative 5 natural log of u. And now all of this, right, is going to be evaluated between our upper and lower limits here of 0 to 7. Okay, well that's not so bad. Here's where things get a little bit trickier, I guess. Maybe that was tricky already. I don't know. Alright, but here's where things get a little bit trickier. Let's put all of this in using the fundamental theorem of calculus, right? The fundamental theorem of calculus says, okay, fine. You can rewrite all of this. Everywhere, the first time I'm going to rewrite this, everywhere I see a, oh wait, you know what I forgot to do? I forgot to put, in place of u, I forgot to put x plus 1 back in, didn't I? Right? Oops, you can't see that. Yeah, everywhere I see a u, I got to put x plus 1 back in, because that's what this 0 to 7 is all about. This 0 to 7 was with respect to x. Alright, so let me do that real quick here. I'm going to do that right now. In place of u, I'm going to put x plus 1 minus 5 natural log of x plus 1 from 0 to 7. Okay, so in place of u, guys, I put the x plus 1 back in. Okay, now here's where things get a little bit trickier, but not really so bad though. I'm running out of room, so I'm going to do this on a separate sheet of paper here. Let me rewrite this. I have 2 quantity x plus 1 minus 5 times the natural log of x plus 1, and all of this is being evaluated between 0 and 7. Okay, so here's where the fundamental theorem of calculus comes in, and it says, hey, the first go around, right, everywhere you see an x, put in a 7, right? Everywhere you see an x, put in a 7. All right, we can do that. In fact, I'm going to do some things along the way here. If this is a 7, right, if this x is a 7, 7 plus 1 is simply 8. So I'm just going to bring that down as an 8 minus 5 times the natural log of, again, 7 plus 1 is just an 8. Right. So there. That's everywhere I saw an x, I put in a 7. Minus, right, minus quantity, everywhere I see an x, now I'm going to put in a 0. Right, I'm going to put in a 0. So this is 2 times, well, 0 plus 1 is 1, so that's just 2 times 1, minus 5 times the natural log of 0 plus 1, well, that's just a 1. Okay, so here I substituted a 0 in place of x everywhere I saw one. Well, let's work this out a little bit more here, okay? 2 times 8, well, that's simply 16. It's not so bad. And I'm going to leave this term right here. I'm going to clean this up in just a second, but for now I'm just going to leave it alone as minus 5 natural log of 8. I'm going to do something with that 8 in just a moment here, okay? But for now I'm going to leave that alone. Minus quantity, 2 times 1, well, that's just a 2. And I hope you see that this thing right here, the natural log of 1, simply means 0, right? You can try that out on your calculator. Do that on your calculator pretty easily if you want. The natural log of 1, right, I've got the natural log of 1, hit the equals button, and you see it just gives you 0, okay? That's because what they're really asking you is, hey, I have a base of e raised to some power, right, raised to some exponent, e raised to some exponent is giving you an answer of 1. Well, anything raised to the 0 power gives you a 1, right? So that's why this thing here turns into a 0, and 0 times 5, well, that's just 0. So that goes away completely. I'm just left with a minus 2 from this second term. Okay, now, to clean this up a little bit more, and I'm almost done with this problem, I hope you see that I have 16 minus this 2 minus 5 times the natural log of 8. Well, 16 minus 2, that's 14. That's not so bad. But I'm going to do one more thing, okay? You probably could leave your answer like this, but I'm going to do one more thing. Could I write, and I hope you agree, could I write 8 as 2 to the 3rd power? Yeah, that's the same thing, right? So I could rewrite this argument in here as 2 to the 3rd power. But do you remember your rules for natural logs? or for any type of log, is when you have an exponent here, you can kick that out front. All right, you can kick that out front and multiply, in this case, times that 5 there. So my final answer is going to be 14 minus 15, and again 15 is coming from this 5 times 3, okay, times the natural log of 2. There you go. That's my final answer for that problem. Isn't that pretty cool? Oh, I love this stuff.